I find mathematics beautiful. The act of stripping things down to their bare essentials creates a certain elegance that you wouldn't have seen if you tried to keep the original problem in all its complexity.
My guest tonight is a UCLA professor who is widely regarded as the world's greatest living mathematician.
Terence Tao.
Terence Tao.
Professor Terence Tao is the equivalent of a rock star in mathematics.
By 9, he was doing maths alongside students twice his age.
I've always liked mathematics as long as I can remember.
People often have a fear of mathematics, that it is just too alien, too different from their everyday experience for it to be useful in their lives. To me, mathematical thinking is just an extension of ordinary everyday thinking. Mathematics is often about trying things you don't quite understand and failing the first time, but mathematics failure is okay. You can just keep experimenting, keep playing. You may not achieve your original goal, but you often learn something. I like to think that this class is for anyone, really. I think everyone has an innate ability for mathematics. In fact, maybe this class is even more suitable for people who have not had formal mathematical training, because they might get more out of seeing what math is actually like. I wanted the opportunity to show that knowing how to think mathematically can be a tool that you can use to solve problems in a systematic way, in a way which can give you reassurance and can make a complex world a little bit more manageable. A large part of this class will be about talking about problem solving. There's a certain way in which mathematicians approach problems. We abstract them, we break them up into pieces, we make analogies, we try to find connections with other problems. So my class is not an advanced math class. I'm not going to write down any equations. I'm not going to give you homework. It's about what mathematics is like and hopefully how some of these problem-solving strategies and thought processes can be of use to you in your daily life. I would like to convey just a little bit of a sense of what it's like to be a mathematician. We are not wizards or aliens. We're just regular people solving problems. So, what are the key takeaways? Well, firstly, mathematical thinking is actually an extension of ordinary everyday thinking. It's not magic. Secondly, it's okay to fail. Failing is how you learn to approach problems differently and find creative solutions. Can't imagine life without math for me. I've always grown up liking maths puzzles, and I've been a mathematician my whole adult life. I really can't imagine life any other way, really. But I remember growing up thinking maybe I should be a storekeeper because I think I can handle, balancing the accounts and inventory. That seemed like something I could do because I had no idea what a mathematician did. I thought that there was some authority that handed them big, difficult problems to solve, and you just handed them back when you solve them. And you almost never see a mathematician portrayed in popular media, except maybe as some slightly crazy genius or something. And for most of my teenage life, I was mostly with kids much older than me. I skipped a lot of grades. In fact, I skipped 5 grades. When I was in primary school, I would take some high school classes. In high school, I would take some college-level classes. My parents certainly tried very hard to balance my math and science type activities with everything else that a kid does. I participated in a lot of mathematics competitions. They're almost like sports. There's a time limit. There's a certain number of questions you need to solve in a certain time. And it's quite different from the experience of mathematical research. The analogy I like to give is that mathematical competitions are like 100-meter sprints, and mathematical research are like marathons. They take sustained effort, and you need a lot of stamina. I was lucky to have many mentors. My first was my mother. She was a high school math teacher. She went through the basics of math with me from a very early age. There was a retired math professor who I would spend weekends with. I remember he had a little journal, a little math journal, where he would write solutions to math problems and phrase them in terms of little stories. And I remember writing one of these stories myself. I was very proud contributing to that journal. As an undergraduate, I had an excellent advisor who recommended me going to study abroad to do my PhD. And when I went to my PhD advisor was very supportive. He gave me a lot of tough love. He definitely motivated me to work harder and to actually impress him. As time goes by, I find more and more rewarding working with the younger generation, mentoring them. It feels good to pass on my knowledge and tips to other people and see them take things further than I ever could. It's very satisfying. I think mathematicians are humans like anyone else. We have frequently imposter syndrome. We feel like we don't deserve to be doing math and everyone else around us seems to be doing better than us because we're always faced with problems that we can't solve. And sometimes we wonder whether we have what it takes. We are intimidated by people more senior than ourselves. I remember as a graduate student, I wanted to meet with a very famous professor once. And I walked all the way to the campus where he was, and I stood at his front door. I was going to knock, this is before email. I did not set up an appointment, and I chickened out. It was just too intimidating. Subsequently, I talked to him much later, and he's a great guy. We were good friends. Yeah, we are human too. We're normal people like everyone else. I think maybe a little bit more nerdy, a little bit more socially awkward, maybe, but still pretty normal. So what life lessons can one draw from mathematics? One lesson that I think really hit me was just how connected everything is. So when I learned mathematics as a student, every single aspect of mathematics was its own separate subject. I took a class in algebra, I took a class in geometry, I took a class in calculus. And then I also learned, physics and chemistry and all the other subjects. And they were somewhat connected, but it was only much later in my career that I realized that all these subjects are really part of a single body of knowledge, and there are so many analogies and connections between these subjects. The way I've heard it described sometimes is that mathematics, when you learn it for the first time, it's like you're looking out at a landscape which is full of mist, and all you see are a few mountain peaks. There's a mountain peak of algebra, there's a mountain peak of number theory, and so forth, and they're not connected. But as you keep learning, this mist lowers and lowers, and you start seeing some valleys. Maybe you see a connection between algebra and geometry. You see a connection between physics and differential equations. And there are more and more of these valleys that appear, and the more advanced your studies are, you see deeper and deeper connections. And then you start seeing sort of all the cities and highways and all the really important connections between subjects that were obscured when you first learned the subject. And so it's only at the undergraduate or graduate level that you actually start seeing all these connections. It's a bit unfortunate that I think all the good stuff in mathematics is you don't get to see until you've been through years and years of training. It was only later in my career that I really appreciated that math is not so much just about solving problems, although that's certainly part of it. But it's about gaining insight, finding connections, seeing that two things are related in ways that no one thought was possible before. And also, sometimes it connects to the real world. I've done many things in mathematics, most of which are very abstract and not super practical, but there were one or two things that ended up having practical value. And so that's also very satisfying. I guess I'm just excited to know what happens next. Okay, so what have we learned now? So first, the more you think about your surroundings, the clearer it becomes that everything is connected. Secondly, math is not just about solving problems, it's about gaining insight, finding connections, and explanations. And finally, the deeper you dive into anything in your life, the more you discover and learn.